Hi, I'm Adam, and this is my cat Charis. How you doing, Charis? We're on YouTube. Note that Charis's almond-shaped pupil has the same shape as that generated by the intersection of the two circles. You may know a circle's area, but what about the overlap? What is the area of Charis's pupil? We'll take a look at that right after this. The overlapping circles diagram comes from Euclid's first proposition, in which we get to construct an equilateral triangle using only a compass and a straight edge. Now, I've had a little trouble with these because my hands are kind of big. And Charis, while she has the right size appendages, lacks the prehensile thumbs. So we found someone with both small enough hands and prehensile thumbs to help us out. Beautiful. Now, if you lack either the tools or the prehensile thumbs, there's always GeoGebra. Beautiful. Now, here's a good spot to pause the video and have a go at this yourself. We'll wait. Charis will take a nap. Ready? Let's go. How do we know that this is an equilateral triangle? Well, we began by drawing the first circle, and then we drew a second circle overlapping with the same radius. The center of one circle is on the circumference of the other circle. Since both circles have the same radius, each of these lines is the same length, so the triangle is equilateral. It's really important at this point that you satisfy yourself that this is indeed an equilateral triangle. If necessary, go back earlier in the video and listen to the explanation again. Or if you prefer, I've included a link in the description to Euclid's first proposition in which we construct an equilateral triangle. Now, let's begin working out the area of that triangle. We've added a mirror image of the first triangle to the diagram. Since each triangle has 60-degree angles, the central angle has 120 degrees. So the red area is 1/3 of a circle. If we decide that these are unit circles, then each has an area of pi, so the red bit has an area of pi divided by 3. But what about these little bits? Let's color them green. We'll get back to them. Let's take a closer look at one of these equilateral triangles. What is the area of just 1/2 of one of these equilateral triangles? We've defined this length as 1, so this length must be 1/2. A little Pythagoras. Shows the height to be √3/2. 1/2 of the base times the height of this right triangle is √3/8. Since we have 4 of these little triangles in the blue area, the blue bit has an area of √3/2. Now, note that the red area consists of the blue area plus the 2 green bits. So the 2 green bits must be pi by 3 less root 3 by 2. Let's add it all together. 1 blue bit, root 3 by 2, plus 2 pairs of green bits, and there's our final result. Now this cat pupil has a name. In Latin, it's known as the Vesica Piscis, which means fish bladder. Many fish have an air bladder which allows them to retain buoyancy at the desired level in the water. So the Vesica Piscis, the fish bladder, provides that balance. The shape has been used numerous times in ecclesiastical artwork as representing the interface between heaven and earth. You have likely seen it represented this way, usually on its side, as a religious symbol. It seems that Charis has an eye for fish. That's it for now. Thanks for watching. Please like, subscribe, and comment with your favorite piece of feline geometry. Check out the Mathderminds blog on Patreon, and if you'd like to see more, please consider becoming a patron. So long for now.